I'm going to displace this, but notice my alcohol is only on the exo side. Okay, so there's no scrambling. You do not get here. Don't get it where the deuterium's up here and the hydroxyl. So, no endo OH group. There is no racemization or anything like that. Okay, we preserve, with this rearrangement, we preserve where our boron was, and we maintain that stereochemistry. Okay, so let's do a couple examples now. Take your boron, your norbornene example. Okay. We're going to do boron THF, followed by hydrogen peroxide and hydroxide solution. Let's compare that. If I did, let's just boil it. Okay, and let's compare that to oxymercuration followed by reduction. Okay, so the first one, not surprisingly, given our previous example, we would say, okay, so I have a hydrogen on the endo side, this hydrogen goes here, my methyl goes on the endo side, and my hydroxyl goes up here. Okay, and that's the only product, okay, that you get. Alright, let's take a look at the next one. And just bear in mind, this is chiral. This is chiral center, chiral center, chiral center. These centers stayed the same. They weren't touched. This is generation of this one. What about this one? Well, I would add my H on this side, no problem. I form a carbocation, which is sp2. So what you would get is a mixture, okay? Because this is going to be flat. Now, could you get rearrangement? Well, if I form a carbocation here and I get the hydrogen here, remember this is already a tertiary. So any migrations that you do, you would still get a tertiary here. So you're not going to get much of a rearrangement in this example. But notice that we're scrambling here. Likewise, Would I have more of one than the other? Yes. Even if it's sp2, just because by nature I'm on the endo side, you probably get less of this. But this one's exclusive. What about oxymercuration? When you do the reduction, it turns out to remove my mercury. It turns out we quote-unquote scramble that chiral center. Because of that, you also get the mix. Okay? And let me just double check. Oop. Yeah, the correct units. This is a hydrogen here, and that's my hydroxyl there. Right? My hydrogen goes on. Basically, my electrophile went here, hydrogen and nucleophile went there, and that got displaced. But you have an anti-Markovnikov and preservation of stereochemistry. This is Markov. So regiochemistry, stereochemistry. This is Markovnikov, and you lose your stereochemistry. This is Markovnikov, and it's not stereospecific. Okay, so of the three reactions, anti-Markovnikov, stereospecific. Markovnikov, you get rearrangements, not stereospecific. Markovnikov, no rearrangements, not stereospecific. Okay? All right. One more example, and then a summary before we move on. Okay. How would you convert? Okay. This alkene to the alcohol. If you look, this is the more substituted. Okay. Carbon, less substituted carbon. This is anti-Markovnikov. Therefore, to do that, you would use borane, THF, hydrogen peroxide, hydroxide. Okay? Suppose instead I say something like, oh, convert 1-methyl cycloheptanol to 2-methyl cycloheptanol. Okay, so in order to do that, let's draw our structure so we know what we're going to do. Here, cycloheptane. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Put an alcohol here. Okay, and then put a methyl group here. Okay, and what I want to do, 1, 2, 3, 4, 5, 6, 7, 5, 6, 7. Okay, at the 1 position, have my alcohol. At the 2 position, have my methyl group. Okay, and like we've done in the past, what I'm going to do is I'm going to redraw this. Okay, and I'll tell you why in just a second. I'm just going to rotate this. One, 2, 3, 4, 5, 6, 7. So all I did was rotate. same molecule. Let me tell you why I rotated it. Okay, so now if I can compare, really it doesn't look like so much I move my methyl group as I move my hydroxyl group. Okay, so let's keep that in mind. All right, let's start working on this. Seven. We have methyl here, hydroxyl there, and we want to find a way to make it 1, 2, 3, 4, 5, 6, 7. Put my methyl here, put my hydroxyl there. So this is still cycloheptanol. This is 2-methyl cycloheptanol. This is 1-methyl cycloheptanol. Now, why did I choose to do that? Because right now, what we know how to do is we know how to make alcohols. Okay? So what are the ways? One, let's work backwards. How do we make an alcohol? To make an alcohol, you have 3 ways. Okay? So, you can hydrate, okay, an alkene. We can do oxymercuration. Followed by sodium borohydride reduction. This is on an alkene. Okay. These two are both Markovnikov. Okay. And then we also know how to do a hydroboration. Followed by hydrogen peroxide, aqueous hydroxide. This is also on an alkene. This is anti-Markovnikov. Do I have to worry about stereospecific reaction? No, but I'm going to include it so we don't forget. This is a stereospecific reaction. Okay. So let's go back and take a look at our example. With our example, I'm moving my hydroxyl from a more substituted carbon, this is tertiary, to a less substituted carbon, that's secondary. So I'm actually doing an anti-Markovnikov addition. Okay, so we're going to choose this step. All right, so I'm going to put in green what it should look like. Okay, so we're doing anti-Markovnikov and we're working on an alkene. So if we work backwards, one, two, three, four, 5, 6, 7. We need an alkene. Okay, right here. Put my methyl group there. Okay. Now, if I do this, then my first step, borane THF. Second step, hydrogen peroxide, hydroxide. And what do we get? What we find is that my hydrogen will go on the most substituted carbon. My hydroxyl group will go on the least substituted carbon. Exactly what we want. So that's good. Now, how do we get an alkene from an alcohol? Well, there's a classic way to do that. Don't we know how to do a dehydration? Okay, so how do we do that? You add in your acid. And you heat it up. going to do is you're going to lose water. And you get your alkene. Well, let's take a look. Does this make sense? If I heat this up, so I protonate my water, or my alcohol group, I heat it up, I lose water, and I have my 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Yes. This is my intermediate. Okay, and it's a tertiary carbocation. So I'm not going to get any rearrangements because I'm at a very stable carbocation. So once this happens, let's take a look at where I can pull off hydrogens. My water can pull off this hydrogen and I'll form my alkene. What's the alternative? Okay, the alternative alkene is this one. The water pulls off a hydrogen here. And what do I form? 1, 2, 3, 4, 5, 6, 7. This is the alkene I formed. But based on Zaitsev's rule, this is minor. This is my major product. Because I only have 2 substitutions. This one has 3. So I'm actually not going to worry about trying to find a different route. I'm going to take this, do a dehydration, form my 1-methyl cycloheptene, right? Then use borane THF complex, followed the hydroboration, followed by the hydrogen peroxide, hydroxide to it, and now I can get my 2-methyl cycloheptanol. Okay, so that's how you want to approach doing a retrosynthesis. All right, let's move on to a different reaction.